today, virtually in isolation. We have attendees today joining us from 34 different countries, which is really awesome. Some housekeeping stuff before we get started. Well, you have all your cameras turned off, so that's okay. But for the browser, seems like Chrome is the best if you have issues with the video or sound. The other thing is to close all the tabs. This may be a lot to ask for some, if you're like me, who like to keep a lot of tabs open. But yeah, it just helps a lot with your connection if you close them. And I'm sure you know how to get them back by going to the history of your browser. The other tip is to turn off, actually close all the applications if you have anything open on your system, and also turn off the notifications by going into the settings page on the right-hand side. And on the notification settings, make sure that everything's ticked off. But otherwise, you get a lot of pop-ups when you are watching the talks. For those of you who don't know, we are a community group based in Melbourne, running regular meetings, trying to cover a wide range of topics in computational design. We are always on the look for speakers, so if you're working in any computational design related field in the AEC industry and would like to present your work, please get in touch using the Twitter handle or the link here. We're based in Melbourne, but welcome speakers from all around the world. Today is also a trial for running the sessions online, and if things go well, we'll soon be having more online events coming up. And before I go to the next slide, I would like to give a big shout out to Swinburne University for letting us use this great online meeting facility and also helping us set up this virtual meeting. So thank you very much, Swinburne. And also to mention that if your internet got cut out during the session and you missed the part, don't worry, we are recording the session, and soon after the session we'll try to make it publicly available. So today's topic is open source software in AEC, as you know. Open source has been loosely described as something people can modify and share because its design is publicly accessible. Now, there's a caveat here before we start to get deeper, and that is open source is a fairly technical and legal term. And for software to be called open source, there are lots of requirements to be met. So just don't take this as a legal advice. What also open source entails is a certain positive spirit that comes along with it, that which is called the open source way. Open source projects and the community around them always embrace and celebrate principles of open exchange, collaborative participation, transparency, meritocracy, and community-oriented development. There are a lot of open source projects in the software world, which has made that industry basically unable to live and go without them. Projects such as Git, the famous distributed version control system, and for example, the widely used Python programming language are examples of open source projects that a lot of people rely on. But what about AEC? Do we have any open source project that the industry can't live without at the moment? This may be a controversial comment, but I personally feel today the answer to this question is no. Although a lot of open source projects are alive and thriving in AEC, amazing projects such as Ladybug Tools, Energy Plus, FreeCAD, and Speckle, to name a few. But open source has not yet been fully embraced by AEC professionals. Our industry is still heavily proprietary dominated. To a lot of AEC professionals, the open source concept is fairly new, and even sometimes weird. They have questions like, why would I share my work with others for free when I can monetize it? Why on earth do I reveal my competitive advantage to others? And if I do that, who owns the IP? Or those who get the concept of open source but still stay away, ask genuine questions like, yes, it is great, but don't I need to be a software developer to be able to contribute? And if I want to contribute, where can I start? So hopefully by the end of today, we'll get some answers to these questions, plus a lot more that's going to be covered by the speakers. Our speakers today are all famous faces and long-term contributors to AEC open source projects. I personally am super excited to have them on board and waiting eagerly to listen to the talks. I know a lot of you are feeling the same too. A couple of things before we start. Firstly, we'll keep the chat open. So if you have any questions during the talks, feel free to send them there. And we'll try to go through them after each presentation. Another thing is that we're going to have breakout rooms after the talks. So if you want to stay for a chat with the speakers, or if you want to get to know each other, and exchange some virtual business cards, you can hang around after the talks are over. And that's it. So now I pass on to our first speaker, Ehsan, who is joining us from the US. And it's actually quite late in there. So thank you, Ehsan, for staying up late to present to us.
Absolutely.
All right. You should be able to share your screen now. And
okay. Let me see if I can get this out now. Share application screen. Hello. Okay. I'll move this to the side and start my timer. Okay, great. Hello, everybody. My name is Ehsan. You might have heard my name related to the PyRabbit open source project that I've been working on for the past couple of years. Recently, I joined McNeil. Robert McNeil Associates is the company behind the Rhino 3D software. I joined this company to sort of like work on the new open source project, AEC related open source project that the company has created. Some of you might have seen a version of this presentation somewhere else discussing the Rhino Inside Revit project. Tonight, I want to show you for basically the time that I have, I want to show you a little bit of what Rhino Inside Revit is, and then talk about the documentation on open. So the importance of documentation on the open source projects, and what the approach that we have taken basically on documenting the Rhino Inside Revit and creating the wiki for it. And I'll show you a couple of examples of the documentation over the PyRabbit project as well. The goal is to sort of like show you what Rhino Inside Revit is, and then show also the best practices in documenting an open source project. So for the first part of this presentation, I'm going to switch over to my slides. And I want to show you what Rhino Inside Revit really is. There are three components to Rhino Inside Revit: the Rhino, Revit, and the connecting part that sort of like connects Rhino to Revit. To talk about Rhino first, Rhino has an amazing geometry engine. This geometry engine has been written in C++. It's pretty low level. It's very memory efficient, and it's incredibly fast. It supports, as far as like the new version of Rhino 7 that's going to come out, it supports subdivision modeling. It has been supporting mesh and NURBS for many years now. So it has a pretty good suite of tools to create many types of different geometries. On top of this geometry API, its geometry engine, there's a Python API. that you can use to basically talk to this geometry engine that do whatever you want to do. It also has C# APIs if you want to write programs in C# and whatnot. But for the purpose of this discussion, I'm going to focus on the Python. And also, Rhino comes with a portable document format. Portability of this document means that there are open source and free libraries out there. There is one that's published by McNeil that you can read and write Rhino models sort of like in any framework that you're on. Even if you're in a browser, you can process Rhino models and maybe display 3D geometry and stuff like that. So the content that you generate and you save in a file is not served in a proprietary format. It's always going to be available to you using the APIs. Now, these three sort of like important pieces is the one that Grasshopper is sitting on top of and it's using. Grasshopper, as you know, is the add-on for Rhino. That's for visual programming. It's incredibly powerful, partly because it's sitting on this amazing foundation and also has a great user interface. And on top of it, it has an ecosystem of all sorts of add-ons and sort of like extensions that has been created for it in the past couple of years. The second part is Revit. Revit has, just like Rhino, it has a geometry engine, but its geometry engine is fairly outdated. It is deeply connected into its BIM engine, the Building Information Modeling engine, which is arguably one of the most important things about Revit. We don't really care about geometry that much in Revit. We care about building information modeling, and we expect the geometry to be generated from that information. It has a really good model and docs API that would let you create different views and different sheets and document things. And it has a file format that is not portable. You can only sort of like deal with this document format inside the Revit context or using the more modern Autodesk Forge platform. And sort of like these components are not really the best. And on top of this is Dynamo BIM, that is the visual programming environment for Revit that's sitting on top of it. It has a really good ecosystem of extensions and add-ons, but also it's kind of limited to what it can do because of this API that's sitting on. So the Rhino inside Revit is this piece that connects Rhino to Revit. Generally, in an operating system, and this is intentional and by design, when you have, if in this slide on the top side of it, if you imagine you have Revit running in memory, and on the bottom side you have Rhino running in memory as a separate application, so you have these two applications open separately from each other. Each one of them runs in a isolated memory space. Applications that the different processes on an operating system cannot access their memory spaces unless it's something that they have designed in their structure and they can communicate over the infrastructure that the operating system provides to it. What Rhino inside Revit does is that so this is not possible. So what Rhino inside Revit does is that it loads Rhino and its host of its suite of extensions and add-ons and plugins and whatnot inside the memory space of Revit. So it basically turns Rhino into an add-on for Revit. What this means is that all these little components inside Rhino, Rhino itself, Rhino add-ons, Grasshopper, which is one of the biggest add-ons for Rhino, and the extensions for Grasshopper, they all potentially can have access to Revit API and the other APIs that are sort of like loaded in the Revit environment. So we discussed this, like Grasshopper having all these different components. Now imagine you also have access to the BIM engine inside Revit, which is really valuable, and the modeling and documentation API inside Revit. The file format, we don't discuss it because it's kind of proprietary, and you can write and read these file format and create content and whatnot as long as you're running something on Rhino over Revit. So you could save and open models and stuff like that way as well. So to show you a little bit of sort of like how this works, I have my instance of Revit running, and I'm going to open an empty document here. And I'm going to the add-on tab, and notice that Rhino button that is added to the add-ins interface. And I'll show you how you can install this and get the Rhino inside Revit here when we get to the documentation part. But basically, all you have to do is you click on this button, and what it does is that it finds the Rhino installation on your machine, and it would load that Rhino installation inside the memory space of Revit. And it provides this connecting piece, which is really the Rhino inside Revit that connects these two together. So it gives you this new tab, and you have access to Rhino, its Python editor, Grasshopper, a suite of tools related to Grasshopper, and we've added a couple of samples at the end of it, just for you guys to be able to play with. So when I click on the Rhino button and I open the Rhino interface, what I'm really opening is the full Rhino application with all its functionality and everything you have inside the memory space of Revit. You still need the connecting part to be able to make these two software talk to each other. And that's one of the reasons that we have started this effort on Grasshopper to create Revit-aware components for Grasshopper that can deal with Revit content. For example, if I draw a wall in here, I'm going to go into the 3D view so we can have a better view of this wall. I can go to Grasshopper, and if you've noticed, there's a Revit input panel, parameter panel on the parameter tab in Grasshopper that I can grab a graphical element, can right-click on it, very similar to how other parameters in Rhino works, and I can grab the Revit element and put it inside this. So you can take a look at this, and it tells me that's a Revit wall. Let's say I want to grab the geometry of this this element inside Revit. There is a whole complete Revit tab that we are working on. This project is a work in progress project. So this is basically what I'm spending my days working on, creating these custom components for Grasshopper over Revit. I'm going to use the element geometry, and I'm going to pass this element that we have selected to it. And you can see the preview of the geometry in here. I can turn it off and on, just like how you're used to Grasshopper to do this. Or if I open Rhino, I can see that geometry shown here as well. You can also, just like Rhino, grab a window out of this, tear off the 3D view, and play with this, and continue working back and forth between your Grasshopper environment that's running on top of Revit and everything else in here. So this is a very short version of the the general presentation that I do on Rhino inside Revit. There's a lot of components and whatnot that they're working on. For example, if I open the Analyze one, you can see that we have components to analyze walls, curtain grids, all the different components of walls, and I'm working on more components for views and everything else that we have for the Rhino inside Revit project. This is as far as I'm going to take this presentation in terms of Rhino inside Revit project. I want to turn the focus on documenting an open source project using the efforts that we have done for Rhino inside Revit. If you guys want to know more about Rhino inside Revit, the content that I'm going to show you on Wiki is going to tremendously help, because we have lots of videos, lots of presentations, examples, and stuff like that, and they're all available through the Rhino Wiki. So one of the important questions working on when it comes up and working on an open source project is that why do you need to document this open source project more extensively, and why is generally what kind of documentations do you have to provide for that? One of the major differences between open source project and closed source projects, I'm going to just generically call them closed source, being the projects that are developed inside companies, and they're generally result in paid applications and stuff like that. You don't really get to see the source code for those projects. One of the main differences between open source and closed source projects is that on a closed source project inside a company, you hire people that you want to work on that project. So you get to filter the type of people that are going to contribute to that project. That sort of like provides a level of consistency over the quality of the changes and the code that goes into that project. For open source projects, you will have contributors that might have started learning Python, let's say last week, and now they're contributing to the project, and you might have very experienced programmers that have been doing programming for many, many years, and now they're interested in your project and they're contributing to it. So you get a very, very sort of like a diverse type of audience and contributors on your project. In my opinion, and sort of like this is the best practice, documenting in open source projects is incredibly important, because you want to make sure that this diverse group of contributors all sort of like follow the same convention and have a unified set of guidelines that they can basically follow and see what they can do when they're contributing to the project. And beyond this, this is sort of like the type of documentation that you need for the developers and the contributors, which is one of the most important parts, because if you don't document your project well, you're not going to get as many contributors on your project in the long run. This is something that I learned the hard way on PyRabbit. One of the things that I did on PyRabbit is that I really didn't document PyRabbit when I started the project really well. So I've been working on that project for 6-7 years, and I know that I did not, like this project did not collect as many contributors as it could have, just of the lack of documentation, sort of like for the project and for the code base. So what we have done for Rhino inside Revit, I've taken a completely different approach. The Rhino inside Revit project, I'm showing you the new version of the wiki that's coming out this week. So if you open the current wiki, which is under the rhino3d.com, which is the sort of like the main page for Rhino 3D. If we'll go under rhino3d.com inside/Revit, it'll take you to the wiki for the Rhino inside Revit project. This new tab that I'm going to open is the new version of this document, this wiki that's coming out that has the more information about the new components and whatnot. So what we have done is that we have created a homepage for the project that is the first thing that basically a visitor to this website sees. And on this webpage, we introduce the project to the user. We make sure we want to get the visitor excited about the project. So we show them various aspects of this project, what it is, what it could be, and how it can help them in their workflows and whatnot. Make sure that this presentation video is fairly short. Like I think the one that we have is about 5 minutes. So it's easy for a person to watch this, go through it very easily, and determine if this is the project that they can use or has the potential to be used for them or not. Make sure the landing page also guides them to the different places that they can go on your wiki. So on this page, we explain all the other buttons that we have on top of the page and explain what each of them are and how they can benefit from them. So the rest of this documentation, this wiki, goes through getting started. Getting started is after the homepage, after we have introduced the project to the audience and we have excited them. We want to sort of like get them started on the project. This should be a very short article, maybe about 10 minutes read. It should have download buttons, installation guidelines, and stuff like that. Just get that user started on using your tool, whatever that tool is. Get them started, show them a couple of features of how this utility works, and sort of like make sure at the end of this article they're kind of comfortable in terms of installing it and running it, and they know what they're dealing with. So they have the playground to play with your tool after reading this article. After reading this, we go to the guides, and this is sort of like specific to the the Rhino inside Revit project, partly because Revit is such a huge piece of software, and it has a massive sort of like data model that we have to deal with. So one of the things that we decided to do is to put the guides right after getting started and make it sort of like break it into the well-known familiar pieces that the users of Revit already know, like how to deal with floors and stairs and levels and walls and all the other parts. On top of this, we introduced a couple of things about how the Revit's data model works, just to make sure that reading the rest of the articles with users having different levels of experience over Revit, they kind of understand, they all have the same understanding of how these guidelines are set up and they work. And we have further broken them down also into what you can do with those elements. So like querying walls, analyzing, modifying, and creating. These loosely resemble the CRUD operations, the create, read, update, and delete operations that it can do on data types. So it basically teaches you how to grab information about walls, analyze them, make changes to them, or create new ones in the Revit model. This guide is meant to be the sort of like the ultimate source of truth in terms of dealing with certain data types in the Revit model. It does not provide any samples. It basically explains how these things work and how they can use the components to perform the task that they're looking for. But it doesn't combine these little pieces into like larger pieces to create more complex Grasshopper definitions and whatnot. That is the part of the same. That's the sort of like the challenge that the samples section tries to address, and it sort of like approaches it on a challenge basis. That okay, so what is your problem that you're trying to solve? You're trying to create a building shell using adaptive components. Here is a video. Here are the sample files. Make sure to explain the sample files, how it works, and sort of like have a description of the sample. So if I want to read through it or reference it later, I can easily reference it, and I don't have to go through your video to try to find what I'm looking for, because it's always easier to run a search over the browser and find the thing that I'm looking for. So you kind of have to always have a combination of guides that sort of like explain how things work, and then provide samples or tutorials kind of thing that approach the problems and sort of like provide an easy solution for the problem, and meanwhile explain how these components and pieces that we have already explained in guides work in a larger setting, in a sort of like a bigger challenge. And at the end of it, you kind of have to provide references. The references are for more advanced users, people that have already gone through the guides and samples. They're kind of familiar, but they still need a place to make sure that they can go and find a component that they need. Like for example, we have a page that lists all the components that we have inside the that we have created inside this project. So it's fairly easy to search this page and see if that's the component that you need. A lot of this stuff can be generated automatically, like this list of the components is generated automatically. If you are documenting any APIs, like the Python API, C# API, all that kind of stuff could be easily documented through easily automated through your build systems and being placed on your wiki system, on your wikis. There's a couple of other pages related to this that are generally touched on at the end of this conversation. Make sure to sort of like include a place for the community and give a shout out to the people that are working and contributing to your project, because it's an open source project. A lot of these people are not getting paid for what they're doing, so this is a really good way to sort of like appreciate what they're doing for your project, give them a shout out, share the content that they have, and help them make a name for themselves and whatnot. It's always a great sort of like approach to create a YouTube channel for your project, so you can share and place all these videos that you have on your wiki on there, and host sort of like, I don't know, live events and everything else. It's a really good platform. And provide an access to the source code, very easy. I'll talk about this source code in a little bit more and what we have done on the source code side. And provide a forum always for the users to be able to ask questions and to have a discussion with you. Now, one of the most important things that a lot of, I think it's really important for these projects, but many projects kind of like fail at this is that they provide a forum for the people to go and have conversations with, but the answers to those questions generally don't leave this forum. One of the really good things about a well-maintained documentation is that as you are going through the forums, responding to the people's questions, sort of like providing solutions to them, you kind of have to go back to your wiki and documentation, keep things updated, grab the stuff that you generated for the as the response to the questions on the forum, place it back on the wiki in a way that's accessible to everybody else. It's not as easy to find stuff in a wiki, especially when you're making in a forum. I'm sorry, especially when you're making the wiki the hub and the single source of truth for your project. So make sure that sort of like loop always gets closed. One of the other things that it has tremendously helped me is that if you create really good structure for your wiki, like for example, under the references, we have a place for, let's say, troubleshooting, a page for troubleshooting. And it has different sections, and each one of these different sections is individually addressable and has a individual URL. One of the greatest benefits of this is that as you're going through the forums and answering questions and stuff, you can share these links to your wiki as the responses to your forum questions, instead of trying to provide linking forum answers to other forum answers and sort of like create all these interlinked forum discussions that's really hard to follow. It's always better to place them on a really good location, really good structured place inside your wiki, and provide those links to the audience. And it's always very easy for you to do this, or if somebody else, if a user have taken a look at your wiki and have found this, they can start answering the forum questions as well. So placing everything in one single place and having this single source of truth is tremendously helpful to attract all the users and all the developers and everybody else that's contributing to your project and using your project to become potential contributor to your project. Whether it's the forum, whether it's the source code, whether it's documenting, helping documenting the wiki, or the sort of like helps and tutorials and all that kind of stuff for a project. And the last part that I want to talk about is that the developer side of the documentation is also incredibly important. So when a developer that wants to contribute to your project walks to your project, they should be able to see a README page on your project that explains the structure of this project, what this project is. If you want to explain the architecture of the code, the build process, how the installer works, how the wiki works, and all that kind of stuff. So make sure this page always exists for the person that walks into your code base. Now, one of the other things that we have done on this project, and I think that's incredibly important, is that the wiki part of the Rhino Inside project also has a massive README file that basically is the meta wiki, as we call it, for the project. It's the wiki for the wiki. And it explains how to contribute to the wiki, like adding a new language, adding a new section. If you want to take Grasshopper screenshot, make sure you take a screenshot like this, not like the other one, because of these reasons. In sort of like it provides the common ground for everybody that contributes to the wiki to know how to deal with this wiki. Now, these kind of articles, you can place them on the code base. They don't really have to live on the major wiki because they're on the backend side. And I don't have to emphasize this because you have probably heard this from everybody that have taught you programming and all that kind of stuff. If you are interested in that kind of things, that you always have to document your code for the automatic documentation. This is a piece that documents this static function, and it explains what this static function does. This is sort of like what I generally call the public-facing piece of the documentation. This is something that the users of this API will see on your documentation website. But never forget about the actual comments and documentation that happens inside your code. This is the documentation that's developer-oriented, the people that's seeing these lines and trying to understand what code does, this is tremendously helpful for them. And if you have to draw shapes and whatnot using ASCII graphics, do that. It makes understanding those code pieces a lot simpler. I can even show you like more crazier examples of this that, for a database transaction component, I've drawn a full graph of like how these transactions work inside the code base. This is not something that's published outside. It's for the person that kind of wants to sort of like contribute to your code base. But it makes it incredibly easy for somebody that walks into your project to understand how this project works, how the code works, and sort of like take it from there and be able to actually contribute to your project. Host, I'm going to leave it at this. I think I'm good for this part of this presentation. The last thing that I wanted to show you is the sort of like the general slide that I have for reaching out to me or everybody else as McNeil. It's called discourse.mcneil.com. That's the forum that we have. You can reach Scott, Kike, or me at mcneil.com, and you can tag me or anybody else on the forum. If you have any other questions, that's a really good place sort of like to ask the questions. I'll respond to those questions. I'll make sure the documentation is updated, and it's sort of like the response sits in a place that's referable, and everybody else can have access to it too.
Awesome. Thank you very much, Ehsan. It was really great. Awesome tips. I was mind blown by the level of documentation in your code and geometry. Yeah, you draw there using ASCII codes. Yeah, I think everyone having an open source project actually appreciates the importance of a good documentation to be able to contribute and also just use the project even. So we have a couple of questions here regarding the Rhino Inside project. Is there a roadmap on next upgrades, developments, or developments of Rhino Inside? They'd like to know if they'd like to know what the team is focusing on in the next months.
Yeah. So to answer your questions, I'm going to start sharing my screen again. To answer your question, we have a so on the references, we have a tentative roadmap for the project that I've sort of like explained in a couple of steps. It's not a very extensive roadmap. I really like doing roadmaps, and I've done it for. I'm going to show you an example for the Pirate project. Pirate has a roadmap, and I like to do it this way, so they know what the next release is and what are the planned features. We haven't really gone to doing this for Rhino Inside Revit yet. There's a lot of exploration that is still happening at this level to kind of figure out what this product can be. Also, I have this challenge of, because I'm the only one with sort of like architecture and AEC experience at McNeil, there's a lot of convincing that I still have to do. I have to get him to agree to certain changes that I want to make. But basically, what we have done, the short version of what we have done is that I'm going to take you through the current version of the wiki that we have. For example, if you go under views, you notice that I've started doing a lot of custom Python components for Grasshopper that you can download using these large download buttons. And these are the ones that we have created, and people have started using them. This was a major effort on our part to kind of figure out what this product is and what kind of components we can create, and how well users can actually use these components in their product. So the current phase of the efforts that we're working on is converting all these Python components that we have created into the actual Grasshopper components. For example, this new update is coming out this week. I'm going to switch to the release notes. This new update is coming out this week, has a video attached to it, and we have added a lot of components that deal with multi-documented and analyzing walls and stacking kernel walls and all sorts of stuff in there. So for the next month or two, what I'm focused on is converting the Python components that I've created over the past 2 months into the actual native code base, and sort of completing these guides and provide as much coverage over the the Revit API functionality. This is sort of like the task that I have on my hand. Kike is mostly focused on the Rhino inside Revit core, getting rid of the bugs, the load bugs, and the element binding and all that kind of stuff. Sort of like the underlying infrastructure that makes Grasshopper and Rhino work over Revit.
Awesome. We have another question saying, when will Rhino 7 be released so that we can use Rhino inside on live projects? But I think we can already use it on Rhino 6.
So Rhino inside, in general, not specific to Revit. Rhino inside is the technology from McNeil, and it's compatible with Rhino 7. McNeil doesn't have an official release date for Rhino 7. We are working on releasing it this year. But you can always get so if you go to the homepage of the Rhino inside, you can get the Rhino work in progress version. Rhino work in progress version works with the existing Rhino 6 license that you have, and the only basically requirement that it has is that you have to update it every 45 days. So you kind of it pushes you to download the new web version and sort of like stay updated. But for the time, like you can start using this on your project if you want to. Basically the biggest challenge is that the project is in beta. Understand that things are going to change, so you might have some of your Grasshopper definitions break every once in a while when you make changes to some Grasshopper components and whatnot.
Right. And I wanted to ask you a general question. One of the frequently asked questions about open source as well. Like, for example, when you have a project in your company you're working on, and you want to like convince your boss to make this open source or something. One of the questions that some people get, come back and ask and say, why would we even think about this when we can like make money from it? What would your answer to that question be?
So to be honest with you, I faced that challenge 6 years ago when I was working at an architecture firm. And I was working on Pyrevit on my own time, and I was using Pyrevit at work. We have been sharing it between the coworkers and stuff to sort of like make the process go faster. But what I did was that so that was it doesn't really directly answer. It's not directly related to your question because the project was my own personal project, so I didn't really have to face asking for permission to make it open source. But one of the things that we did is that we started collecting data throughout a year in terms of how this project is actually improving everybody's workflow. So after a year, I went to my boss and I showed him that this is the project that I've been working on. Some of the time on this project has been spent when I was working in this company and whatnot. This is the number of hours that we have been able to save throughout this time. And I kind of like showed him the project, and I showed him the pieces that are potential business advantage and the pieces that aren't. Like, for example, one of the basic examples that I showed him was that the pattern maker in Pyrevit. And I told him that we have had pattern maker for past 20 years when we were working AutoCAD, and then went to Revit. We still have the infrastructure, but we just don't have any other pattern maker. So we kind of stuck on this. This is not a technology that's new. It's not a business advantage. It's something that everybody should benefit from. So I think the sort of like a clear conversation with the management is incredibly important, and make sure to bring in the people on your team that have a really good understanding of how the management how the management team works, so they can be the bridge between the actual developers and the people that are excited about the technology and the people that are sort of like their goal is to maintain the company and make sure it's profitable and they can pay everybody's salaries and stuff. And I think for me, at least in my example, that clear line of communication was the winning ticket for me.
Yeah, thank you very much, Ehsan, for your time. I can see from your screen that it's getting close to 2 a.m. there.
Yeah.
So we don't want to get you up anymore. Thanks again for joining us.
Absolutely.
I have a lot more questions, but hopefully we can find you on the forums and stuff and ask more questions. So next up, we have Dion. Dion. Dion has been developing software for a long time, but recently been working on an exciting project called Blender BIM, which brings basically BIM authorship capabilities to Blender, which is itself also a big open source software. If you haven't already checked it out, make sure to go to its page, and it has a separate website. So I highly recommend that. So Dion, are you all set to go?
Hopefully, can you hear me now?
I can hear you loud and clear.
Great. Okay, so let's try share content, share application, entire screen, and hopefully you can see my screen. So thank you for the introduction. The website, if anybody is interested in the project that I'm currently spending a bit of time on, is blenderbim.org, and it does bring open BIM authoring, consumption, interrogation, analysis to Blender. And this is a little bit different to the previous project because this is 100% open source and free software, whereas Rhino side is not what, if you sort of mingle around with the open source community, they don't really, I don't think they would consider something like Rhino inside to be free software, because the whole stack is not free, right? Rhino is certainly proprietary, as is Revit, whereas in this scenario, the add-on is open source, but the entire stack is also open source. You don't need to run it on Windows if you didn't want to. So for example, I have run Blender on my phone on a totally custom version of Linux on my phone, and then actually authored a BIM model on my phone, which is something a little bit different. Anyway, so here's my little presentation. I've been doing open source contributions for a long time now, well over 10 years. I also have a training in architecture as well as in computer graphics, modeling, animation, things like that. I put this slide here sort of because I thought maybe I should talk about BIM a little bit, but this is kind of like the obvious stuff, like we get it, you know, proprietary stuff is incompatible and your BIM data expires after 3 years and your business is locked into other businesses' release cycles and off-the-shelf capabilities. And I didn't really want to dwell on this too much because I think the big issue with open source in the BIM industry is that the culture is not there. I mean, this shouldn't need to be a slide that I need to put up. If I were giving the same talk to a group of CG artists, I mean, they wouldn't understand this slide. It doesn't make sense to them. If I were giving this talk to a bunch of computer programmers, their culture is so embedded with open source, they cannot build things without it. They cannot, you can't create a Hollywood movie without open source. It's not possible anymore. So it's something a bit strange that it's so new to the folks in the AEC industry that I need to sort of talk about this. So I thought instead of talking about BIM, which I'm sure everybody will be talking about, I wanted to expose a little bit about some of the great open source applications out there. And the first one is Blender. Blender is a 3D content creation suite. You know, it does modeling, animation, rigging, texturing, sculpting, compositing, you name it. It does it. And this is a very, very old application. And it was sort of built by craftspeople. You know, you talk to BIM guys and people who model and add metadata to buildings, and largely what they're doing is off the shelf. Whereas the same time, a long time ago in the CG industry, it was normal for people, for every single CG studio to sort of create their own 3D modeling program. And just kind of like how artists a long time ago, they would mix their own paints or would carve their own sculpting tools. Every single CG company would actually create their own 3D modeling package. And Blender was one of these 3D modeling packages created for in-house use to create 3D work. And the company went down and they thought, this is such a great tool, let's open source it. And it's extremely successful, and to this day, it's used in the pipeline of so many Hollywood movies. It started in Spider-Man 2 back in the day, which was, this is the one with Tobey Maguire, I think that's the actor's name, so the really old one. And now it's used heavily in game design. It just receives, millions of dollars in grants from, I think, Epic Games or something like that. And that's because they understand that it's not about the tool. The tool doesn't give them a market advantage. The market advantage is the artist. You don't get hired by Pixar because you know how to use tool X or tool Y. You get hired by Pixar because you're an amazing artist and they see that ability. And once you get hired, they say, great, you have 2 weeks to learn our tool, which again, they built in-house, and some of it is open source, some of it isn't. And you just learn it, and you do that because you understand that the tool is just better paintbrushes for everybody in the industry, because the world needs art. The world doesn't need paintbrushes. The world needs, really good art. And I think the building industry doesn't quite get that. The vendors think that they need better BIM tools, whereas what we need are better buildings and better built environment. And the only way to do that is to stop fighting over the best BIM tool and just work together and make sure that our BIM tools speak together so we can get the relationships that we need. I wanted to branch out a little bit to demonstrate just how foreign all of this is in the built environment. So I don't know how many of you recognize that icon in the middle of the screen. That icon is the K desktop environment, or KDE icon. And KDE is the world's second largest open source project. And you get thousands of people contributing to this every single day. And what it is a graphical user interface for the computer. And you can use it on Windows if you wanted to, but not so many people do. And the idea is that the graphical interface that you see on your computer, which provides maximize, minimize, taskbar, and all of that, that's just an application. But you don't need to be content with what Mac or Windows gives you. There are actually hundreds of possible graphical interfaces to choose from. So for example, right now, I am running, you'll notice that there are no taskbars on my screen. My screen is actually a bit like an Excel spreadsheet. You can see that I am splitting it into various cells and merging cells, and there is no mouse interaction whatsoever. And KDE is one of these graphical interfaces, which offers you different ways of working with your desktop. And what's quite amazing, and it's the same with the Blender project, but I'll give some examples from KDE, is that this is where innovation truly happens. Because the people who are building KDE are not people who are paid by a company to deliver, whatever they've written in their roadmap. They're people who just like graphical user interface environments. They just love it for whatever reason, and they just want to build really cool, funky things. So the things that you see get released to Windows and Mac, things like global desktop index search and virtual desktops with 4 or 5 virtual desktops, and desktop effects with compositing and shadows and transparency, and or even like widgets, which were made popular in Mac and Vista desktop widgets. All of those, long before they came to the Windows and the Mac world, were actually prototyped and used for many years in the Linux world, in these variety of graphical user interfaces. But so many people are unaware that this amazing stuff is happening because they live in this sort of bubble of proprietary, marketed, off-the-shelf work. And I see that every day in the AEC industry. You're just not aware of what's possible. I mean, just going back to Blender for a second, you walk into a room of CG artists, and everyone on their screen is creating an amazing universe that they're so absorbed in, and they spend time refining their art and pushing the boundaries of what's possible. And then you walk into a room of architects, and everybody's kind of looking at just 2D and struggling to get 2 boxes to line up, and the boxes don't quite line up because modeling is hard. and then you have this crazy bug creature that's being made in the other room. This is another one, Gentoo. Again, maybe you haven't heard of this. This is a Linux distribution, which allows you to basically build your computer from scratch. So not hardware, but software-wise. So the ability for a computer to understand that it is a computer. I won't spend too much time on this because it's rather technical, but this, for example, is what I'm running on my computer right now, and that's a screenshot of a cow on the top left, which is what I can run on my phone, which turns my phone into a desktop computer, which I can then run effectively BIM applications on. But there is this sort of trade-off you get with open source applications sometimes that I want to communicate here. Because open source applications are heavily developer driven, sometimes it's not so easy for users to see what's possible with it. And it requires a level of technical understanding, and sometimes that's a good thing, sometimes that's a bad thing, because it's a trade-off with more powerful tools and more flexible tools. There is a much steeper learning curve, and sometimes it's worth it, and sometimes it's not. But what I don't see in the industry are people really willing to put in this effort, and maybe that's just what I've been exposed to, but just relative to other industries where people spend time to really dig and peel away their tools and improve it. I don't see that in BIM, and you see pockets of it here and there, like Speckle and so on, but it's quite small. This might be a much more familiar project. By the way, all of the names that I'm mentioning here are projects that relate a little bit to AEC. So Radiance is one that I contributed in a little bit, and Radiance is a light simulation engine. And it's one of 2 validated light simulation engines in the world. The other one is called AGI 32, and it's proprietary. And what I mean by validated light simulation is that when you create a render out of it, or a set of lighting analysis out of it, the results are photometrically correct. They are tested in a laboratory environment. And this is, again, open source application, and many of the tools which for example, Ladybug or Honeybee, are actually using Radiance under the hood, and it wouldn't be possible to build them if Radiance did not exist. It would be a lot harder. And a lot of the building physics engines that we use today, like Energy Plus or OpenFOAM, are actually open, because academics need to do that to validate the calculations are correct. So what you see on the screen are 2 images, and the one on the right here is a photograph of my very messy living room before I moved house. And the one on the left is a render of the same scene. But this is not a normal render. This is actually a light simulation created directly from a BIM model of this room. And this BIM model was created purely using open source software, using Blender, in fact. And it goes down to the detail of the geometry, down to the every single blade of grass. Every single blade of grass is a BIM object, or rather, or related to a BIM object, as is the cloth on here, as is the curtains, as is the lights, and contains photometrically correct data. It was not created by a CG guy who you hire, a CG artist who sort of creates a bunch of test renders and tweaks the colors until it looks right. This was done blind. In other words, you measure using scientific equipment various colors and material data of surfaces in controlled environments. You put it all into the BIM model, and then you simulate it. And you can see the similarities between the one on the left and one on the right. And it shows just the level of detail and that you can get out of a BIM model that is sort of sort of photoreal and kind of beautiful in a way emotionally, but it's also scientifically correct and photometrically correct. And at the same time, it's also semantically rich and queryable, because it's a piece of BIM data, and it's all reusable. By the way, this is an open data project, so you can actually download this and get all these BIM components. It's all done in IFC, so you can dig into it and do whatever you need to do. FreeCAD was mentioned at the beginning. FreeCAD deserves a huge mention because FreeCAD was one of the first truly open source BIM, as in full stack open source BIM programs out there. There's some absolutely great developers behind it. They do CATIA style parametric solid modeling. And they have some really innovative functions in here to query BIM data and spit them out and slice and dice them that I unfortunately do not have time to go into detail. But some of the guys who use FreeCAD, they work with a company called Opening Design. And they work in a really interesting way. They work as an open source workflow, because it's not just about the technology that they use. They open source their workflow. So you can actually download a BIM model anytime throughout their workflow, and you can edit it just like Wikipedia, and you can go and resubmit the BIM model to their repository. And anybody can do this, and there are people just sharing all of their BIM models to create real commercial work in a completely open source way. The guy behind it is Ryan Schultz, absolutely amazing, forward-thinking guy. They do use some proprietary applications, because at the same time they're realists. They know that there are certain features where the open source equivalents aren't quite up to scratch yet, but they are really pushing the boundaries. So, and these are fully engineered, small to medium-sized projects, not very, very large commercial projects, unfortunately, but it's getting there slowly. OpenStreetMaps is something else which follows the kind of Wiki model. It's an open data set, where this one I think many people here have heard of. It's a map which everybody can edit. And again, you can see the difference. It's not just about whether something is technologically superior or inferior. It's about whether people care. And I think if you look at OpenStreetMaps, especially where humans have mapped it, you can tell that people really do care. Because on the left is Google Maps, and the Google Maps doesn't make profit off the DRC. But OpenStreetMaps understands that all these organizations on the top left, they need to do all these things on the top right. Medical supplies and logistics and humanitarian aid. They need this data. And so in one evening, you had 70 people who came together, understood that need, and they built this map free for everybody to use. And I think that's the type of culture which is missing. If people thought that was a more normal thing to do, I think the industry would be in a very different place than it is today. I do want to give a bit more shout out to this program. This is Blender BIM, the thing I'm making. This started off, this is based off Ifc OpenShell, which is a library that allows you to query, read, and write Ifc data. And it basically brings BIM functionality to Blender. I guess I didn't really plan this, but I might give a short little demo, so hopefully you can see my screen. So I've just started up Blender. Here's a cube, and you can see on the top right, I have a cube, a camera, and a light. I'll quickly set up a project which has a site and a building in it. You can see various things I can call my cube. I can call it a wall and assign it to my cube. Throw it in that story, file, export. We'll call it test.ifc. I'll start a new file, delete that, and now I will import that file which I just created, called test.ifc, and voila, I have my wall cube thing. So that's me creating a BIM model in about 5 seconds. But there's, of course, much more features than that, but I don't want to bore you too much about it. I'll give you a brief overview. It supports property sets and aggregations. You can create your own property set templates if you want to define various standards of what properties can be stored in a model. The usual types of classifications we see here, uniclass, and there's omniclass, and you can get many more online. Searching, you can do reject search and analysis of your models. Pulling IFC data in and out of CSV format to do bulk modifications to IFC data. It supports BCF as well. Different types of contexts. So you can actually create BIM models which store things like clearance geometry or footprint geometry. If you want to actually store a 2D plan in an IFC file, you can absolutely do that. It's got various types of quality auditing tools, connects to BIM server, georeferencing. You can compare between 2 different IFC files, and so on and so on and so on, which I don't really think it's too important to go into the detail, as it changes every week anyway, so that will be outdated by next week. So there is a huge amount of software out there, and software is not the issue. Other industries have sort of progressed to a stage where they know they can't work without open source software. The internet, for example, cannot function without open source software. It's the very fundamentals of what connects internet networks together are open source. You'll see some names here which are not what you might think are open source. For example, Goldman Sachs, which has a lot of their financial libraries made open source. OpenSSL, which is to do with cryptography. Government standards of security has to be open source. They can't trust proprietary security protocols because they're closed. You can't inspect them. And I wasn't sure if people would go over this introduction before, but this is kind of like the canonical definition of open source. And open source is kind of a term that's frowned upon. It's because it doesn't really connote what's important. The fact that the source code is there is nice, but that's not the important thing. The important thing is the fact that it's free. And when I say free, it doesn't mean you don't pay money to it. You can have free software that you pay money to, but it's that it gives you freedom. It's about liberty, the ability to run the program for whatever you need. In this digital age, being able to have tools to do what you need and run for any purpose is equivalent to like a human right almost. It lets you have freedom to do things, to copy and study your environment, especially because the digital world shapes our lives so much nowadays, and change it and improve it are sort of, this is like the statement of digital human rights if one existed, and that's what's important. So when somebody says something like, this program, the source code's available, like what was that? What's that game engine that was not Unity, the other one? They were saying, oh, we're open source. They're not. They call themselves open source, or things which say, oh, this is an open source add-in, like the Revit exporter is open source, but the entire stack underneath it isn't. So it's still sort of handcuffs your business. And I just want to emphasize it's not the technology, because I mean on the left here you can see Revit, and or not just Revit, Autodesk, and this is a list of all of the open source technologies used by Autodesk software. There are 264 items on this list. Legally, they have to write it here. They don't advertise the fact that they use a lot of open source software, but legally they have to put it in here. And I guarantee you that the development time would be greatly multiplied if they were not able to reuse so many open source applications. And on the right is a currently growing list of the AEC free software directory. So this list actually excludes things like Rhino inside, and also excludes other types of open source offerings that are not full stack. So for example, you won't find Honeybee and Ladybug here. But there are nearly 100 items on this list. We're approaching 100. And there's a lot of tools that we have that we just don't, we don't really understand how to tie together, or people aren't investigating enough. And it's not because the tool is there or that the potential isn't there to turn it into a great workflow. It's just that the culture isn't there. And culture is a really hard thing to change. And I think maybe the first thing to do is to step back from open source and get people to understand open data. And it's kind of like the Babel language, the universal language to allow things to interoperate. And regardless of your stance in open source, most people kind of agree that interoperability is kind of a good thing. And we've been working a lot in silos, and there are lots of technologies. You can see here, IFC, of course, is the big one in BIM, but there are so many more that allow us to describe our assets in incredible ways. Like, for example, SVG. If you use SVG for documentation, all of your styles can be applied on runtime, not prior to generating your documentation. So you can reuse the same floor plan with different styles to describe many different things, and by hiding and showing and changing line weights and thicknesses and all the rest of it. It's a different way of thinking that may not be so obvious if what you're used to is kind of the older approach. But anyway, that's just a brief example. I think I've been talking for quite some time now, so here are some random photos I found of various cool open source things. If you go to the Building Smart website, that's technical.buildingsmart.org, you can see a list of various open source implementations of the IFC standards. If you haven't started learning a bit about IFC, I think that would be a very good thing to do. Of course, this website is here. There's also the newly created OS Arch website by a group of free software developers and architecture folks, which has a wiki, which has various types of resources you might be interested in. It's still very new, so we're just getting started, as well as a small little forum here. And hopefully that might be some of the things to look at, but let's see, how am I doing for time?
I think we have time, so if you want to go on, should be all right.
Yeah, sure. What was I going to show about? Let's see here. Hear more about your plugin. Yes, yeah. Well, the easiest thing to do is actually just see the plugin. So as you can see, the plugin completely decouples geometry and data. As well as, for those familiar with IFC, you'll notice that all of these fields, they highly reflect the type of data that you'd see in an IFC file. And it sort of, and that's one of the issues with the BIM applications we have today. The reason it's so hard to get them to interoperate is because they're so old and have a lot of legacy behind it. They have to translate from their internal data model to this open data model and back again. And so you get this kind of really sad thing happening in the industry where you say, oh, let's interoperate, let's use something like IFC, and then you export your model, and during the export process, half your data gets lost. And then you give it to somebody else, and then they import their model, and then during the import process, half your data gets lost again. So it's not very useful. And it's because of that translation process, whereas the way this plugin is built, it basically mirrors the IFC schema. And in fact, a lot of this is generated. It's not actually coded. So if you wanted to really learn more about IFC data, I see another question there, how it's not very developer friendly. I disagree. I think it is quite developer friendly. So for example, what this comes with is a Python console, and you can write scripts and so on. There's also a text editor if you want to load up some scripts and so on. But I'll show you what's it like to query an IFC file. So I'll import this library here, and this file which I've loaded comes from here, home Dion tested IFC. And that's my file there. And I can search for various objects in it. This is not a very interesting file. It's just got one IFC wall in it. So I can get that by searching for all IFC wall, get the first one in there, that's my IFC wall, and I can find the name of my IFC wall, which is cube, which corresponds over here. And that's like, 5 seconds or so. It's not difficult. I'll show maybe a slightly more interesting model. Sorry, let's just start a new file here. Don't save, delete, and let's import IFC Open House. So this is an interesting model because this was not modeled with an interface. This was actually programmatically generated. So it's a nice little interesting test model. It's pretty old nowadays, but it's got a bit of data in it. And it's, again, I'll just zoom into that just in case it's blurry on people's screens. And again, I'll do the exact same exercise with hopefully a bit more data in there. And there you go. We've received a bunch of walls. You see the first one in that list, the name is this. And if you want to learn a bit more about IFC, this is a great way because It allows auto-completion, so you can see all of the various attributes on an IFC, so you can sort of just explore without having to read all that really complicated documentation that Building Smart likes to produce. And at the same time, you know, if I click on a wall, you can see the various types of classes which can be assigned. It's not that many at the moment. And if I click on wall, you can see, okay, there's a movable wall, a parapet wall, a partitioning wall. Sometimes these things aren't shown a lot in other BIM programs. It's kind of hidden from the user for some bizarre reason. You can see, okay, here are the property sets that can be assigned to a wall. You know, some things can be assigned, some things which can't. You know, what's in the wall common property set? You add that. It says, oh, there's a reference field, a status field. And it sort of explains it to you. It doesn't let you sort of guess at what can you assign or not assign. It tells you what attributes are possible. You say, okay, I want to add a tag attribute and give it some data, blah. And or let's say I want to edit a few things in bulk. So let's go and into CSV. Let's select all IFC wall things, and let's say I want to know their IFC class as well as a name attribute, and we'll export that to a CSV, call that test. And there you go. Here's a CSV file. I should probably open this in a spreadsheet program, but you get the idea.
Dion, while you're at it, I have a question about UI and the user friendliness in open source projects. We have a lot of examples in open source software in AEC where there has been like minimum effort to make the end result looking friendly to the user, especially if like they are not so software savvy. Normally the icons are poorly designed or there's no icon at all. Everything is like text-based. Take most of the, like, for example, IFC exporters, importers, for example, users have to navigate to a long list of text and IFC classes to assign their objects to the right class. Well, the Pascal case naming conventions like scares a lot of beginners away. And apart from the classes and object properties, shouldn't we also agree on a certain standard on a UI for OpenBeam, so that and it gets easier to use? For example, like standard icons for walls and things like that.
Look, and I see what you're saying. I think that the thing about open source is that what happens is what people want to happen who are engaged with it. You're not in control of an open source project. Even if I wanted that to happen, then I could only build what I can do in my own time. I can't force somebody to build something because I want to. It's not like in proprietary that there are no roadmaps. I can't say, oh, I want you to use this icon because I think it's better. If something is truly objectively better, the open source guys do have a culture of meritocracy, so it will be adopted. But the first step really is culture and people to engage. And if people don't engage and say and put in that step, then it will never happen. So, and yes, sometimes that means that the user friendliness isn't there, as I showed with the Gen 2 project. But it takes time. So, for example, Blender is used by artists. There's so many people who are using Blender that shy away from code. And that's okay, but it took a while to get to that step, and there are a few prerequisites, I believe, for that to happen. And the first thing is culture, but culture is so hard to change. We're so far behind in the AEC industry. Maybe the first thing is just understanding a bit more about open data.
Could you also expand a little bit more about one of your first slides about why proprietary software is bad? Like, I'm sure a lot of people will be interested to learn more about it. I mean, with the proprietary software, one of the things that you get is a support feature that you might not get it as strongly in an open source software? What would be your answer to that?
Just speaking from experience, I found that when a open source application is actively being built, the support is actually much better in an open source program. Much, much better than any proprietary program. When an open source project is abandoned, yes, then the proprietary applications generally get much better support. But otherwise, the open source ones are much better supported. I mean, let's say on Microsoft Windows, you get a bug on Microsoft Word, or you're trying to get it to do something and it can't do it. You can't just ring up the developers of Microsoft Word. Whereas in open source, I can actually do that. Like if something's broken with my start menu or equivalent or whatever, like this random little program I'm using to display my clock in the top right, I literally within an hour can get it fixed, and an actual developer who wrote the code to make that work look at it. And that's who they are. They live it, they breathe it, and that's in their culture. They want to be there for you. In Blender, I had a bug the other weekend, and I reported it, and 24 hours later, it was fixed. And people who have been using Blender BIM generally have the same thing. So for example, there was a bug here, and this is, we'll go up here. This was 12:30 a.m. There's a bug here. 7 a.m. I say it's a bug. I will fix. 8:30 a.m. It's fixed. I mean, and that's always happening. And I guess the person in the comments who said that's true. Autodesk is a prime example of that. I do want to jump to this actually, because this is a very interesting question.
Yeah, please.
Documentation. We talk about let's do BIM, let's do models and all the rest of it, but you look at the industry. What actually makes a good, popular BIM software is not its ability to do BIM. It's the ability to create documentation. There's a reason why there's so many 3D modeling tools out there. Rhino is absolutely great for modeling certain things that Revit, you kind of look at the 5 modeling buttons you get and you kind of have a large drink of water because that's all there is. But you use it because that's the only thing you can create documentation out of. And that's really, really lacking in the open source industry. And there are open source BIM programs that can produce documentation. Blender BIM can do it. What else? FreeCAD can do it. But at the same time, I wouldn't call it easy yet. So if I scroll up here, if I'm lucky, I might find a screenshot of some documentation that was done. No, I'm not lucky today. But for example, there was a small project which was done purely with Blender BIM and FreeCAD and no Autodesk software being used. The full documentation, we built all of the tools to create sheets and views and all the rest of it, pure open source. That was done, and a small building was built and delivered. That's been achieved. I wouldn't call it ready. It's something that needs to be solved, and IFC makes it difficult to do that. IFC does a lot of things right, and there are many reasons for it doing what it's doing, but it also does some things not quite so right and many improvements to be made. And one of the facts about IFC is that it supports so many types of geometry. And what you need for documentation is an incredibly reliable way of doing a Boolean cut, because that's what a plan or a section is. It's a Boolean cut. And Revit does a great Boolean cut because the objects in there are safe. You can cut them. But once you move into IFC land, and if you dig into the IFC specs, you'll find 200 ways you can store geometry. Oh, there we go. Here's an image of a kind little piece of geometry in there. There's a few more hiding around, but it's not there yet.
Awesome. Thank you very much. I'm sure there's a big round of applause at the moment happening. Everyone's muted. You can't hear them, unfortunately. But thanks again. It was really awesome and informative. And if you can please hang around after the talks, the next talk, so we can have a chat with attendees in the breakout rooms. That would be great as well.
Absolutely. Thank you.
Awesome. So next up we have Jon. I don't think he needs any introduction, so I'll pass on to Jon without further ado, and let's start.
Okay, great. Thank you.
Thanks.
I will introduce myself just quickly because I'm sure not everyone knows who I am. I basically did a double degree at Melbourne University, majoring in structural engineering and computer science. I worked for about 5 years in Melbourne. I went up to London and worked for about 5 years there. And then just over 10 years ago, started a business called Geometry Gym, which is basically specialist software tool development and consultancy. I guess I was very spoiled for projects that I could work on. Lots of stadiums, bridges, a couple of towers. The interesting parts of those is that often, particularly stadia, the geometry is celebrated. So there's a lot of effort put into the structural geometry. And I guess armed with a computer science degree, I was always writing lots of scripts and spreadsheets trying to build the models of these projects using the computer science training that I had. I'm pretty proud to say Geometry Gym is just turned 10 years young, basically. It, as I said, evolved out of projects, tools that I wrote to help do my job. I learned about Rhino when I moved to London, started writing some Rhino plugins, Grasshopper emerged, started writing some Grasshopper plugins. They were helping me do my job and others in the office, and then starting to let other offices use them and trying to a crack at full-time working on these tools. Some of you might have seen me post this image earlier this week. So this was like the first ever IFC import model I was testing when I was developing IFC import, which is the Australian Institute of Steel Construction model. And so 10 years later, I'm still working on it, which is a great achievement because I know a lot of businesses don't make 10 years. And I'm going to talk a bit today about what we have done that's open source, a lot that we haven't done that's open source, why that is, and I'm also going to probably concentrate a bit more on open standards and IFC as a data model to help facilitate open source or closed source BIM exchange and interoperability. I think we did trailblaze in a few ways. We, for example, and this is probably a strange thing to say in an open source discussion, but we were the first firm that I know of to charge for a Grasshopper plugin. And as I said, I'll talk a little bit more about why that was or what led to that sort of decision shortly. As I said, we've really focused on interoperability. Anyone that's worked on a built environment project knows that today there's probably lots and lots of different models created in lots of different applications by different participants on a project team. So you can have an architectural model, a structural model, a fabricator's model, a contractor or a builder's model, and maybe an asset and operation model downstream of this sort of thing. So we certainly specialized and focused on interoperability and how you can get the most intelligent model data from a sort of single source or a shared source, rather than build and maintain lots of different models of the same thing. And I guess a lot of us are very quick at building a model, so we might generate a model quite quickly, but the project design evolves, and then there's lots and lots of changes and coordination, which is not so quick and efficient. So there's certainly a lot of gains to be done by interoperability if you can reduce the number of models that are required. Sometimes I've done a presentation, and the first question, or the question I've been asked then afterwards, is what is IFC? So I try not to neglect what IFC is. It is a data model. It's object-oriented set of classes, hence called the Industry Foundation classes. And it's had lots of time poured into it by Building Smart. So I'll touch a little bit more on that again in a minute, but I often show this video, the end of Babel, at presentations. I won't show it now. You can look it up on YouTube and watch it yourself, but this will do a much better job at explaining why interoperability is such a problem, issue, and challenge, and how IFC and what Building Smart are doing, looking to address and improve that situation. So my own personal contributions to open source, I'd describe my contributions as modest. And I've been fortunate to have been funded for some of those contributions. I'm going to have a quick look at them in a second. Certainly at Geometry Gym, I'd love to do a lot more that's open source. We've certainly considered it at various stages over the last 10 years. But I guess there's a hesitation as to how that could be facilitated. And certainly I'd be interested in discussing with others on the call later and get other insights. And we've heard from the other presenters that have done a lot more in open source. And I'd like to thank all the open source developers that build and provide various software and code that we, as Dion and Ehsan said, we build on top of. The main open source project that I've done with Geometry Gym has been an Ifc Toolkit. So I actually developed that closed source when I first started considering to support Ifc, working on a European project with BIMForce in the Netherlands, decided to open source the toolkit, and it really just writes and reads Ifc files across different versions. It doesn't have lots of interfaces to Rhino Common or Revit. We've basically Geometry Gym built a bunch of development on top of that are closed source. So, but the main toolkit for reading and writing Ifc is open sourced, and that does include different serialization formats, including XML and JSON, which is certainly something I've seen in the chat from Alain, something that we're also very keen on. Some other open source projects by Geometry Gym are just some examples of how to use the Geometry Gym toolkit. I have been as a technical support to Building Smart, been involved in documentation, the tool Ifc Doc. So I've done some development work on that, and that's how the Ifc specification is stored, and the verbose documentation that Dion was talking about is produced from that tool, at least at present. And the other open source project I've done a bit of support work for has been the Revit Ifc import and export. So Geometry Gym started working on their own Ifc importer for Revit about years ago. Autodesk recognized that I knew the Revit API and Ifc quite well, so I have done some work for them involved in their open source project for importing and exporting Ifc. I guess if time went back in time and they'd open source me start my own plugin, maybe things would be in a different situation, but I was already a couple of years into that by the time they did open source. I thought it might be interesting as well just to have a quick look at what open source projects that we utilize at Geometry Gym and help clients utilize and their interest, particularly myself. So I've had a great presentation from Ehsan about Rhino Inside. I think that's a really interesting, in many ways, strategy from McNeil. As Dion's mentioned, it's built on a closed source stack, but that's part of the reason how it can be open source. They can fund and employ developers to work on it, as well as get contributions from the external community. OpenNerbs and Rhino Common has been open sourced for a long time, which is the ability to particularly read and write 3DM files with also quite reasonable functionality on vectors and the more primitive geometry things that are the more advanced features are in the closed source Rhino, but they have been quite generous with Rhino Common, and that's certainly something we use a lot in pretty much all of our tools. Vim's a slightly abstract open source tool. It's a text editor that minimizes the interaction by using a mouse. And having studied computer science at Melbourne University in the late 90s, that was drilled into us to use Vim to be efficient, and I still use Visual Studio Vim, which probably makes it hard for anyone else to use my computer in Visual Studio. Speckle is, I'm going to touch on a little bit more in a second. Dynamo is well known by the community as an open source project. And then a few others like NewtonSoft is used in a lot of closed and open source projects. Excel DNA I used a lot early in work with Excel plugins. BCFer by Mattia, who's also at Speckle, is a very interesting project. FreeCAD Blender Beam I don't need to talk too much about. Hyper is emerging at the moment. Edo, which is cross-framework user interface or cross-platform user interface, and even .NET itself as a development environment is being open sourced more and more in recent years. So I guess to give some comments and insights into Geometry Gym with its relationship with open source, the AEC industry is a very competitive market, so it's kind of a huge leap of faith for Geometry Gym to turn out and open source all of our developments, and how will we earn revenues in the sustained developments and support. When I didn't set out to, well, I set out 10 years ago wanting to work full time on the development of it, and charging the users seemed to be the obvious way of trying to do that. We did bootstrap the business, so it's self-funded, and I did extra training and consultancy and stuff in the early days. But yeah, for the last, for a significant number of years now, I've been and been able to grow the business and add Scott and Nathan to the team, which is very encouraging. Geometry Gym is a small company. It's a trailblazer and innovator, so I'm not absolutely sure that trailblazing is that as well suited to open source. A lot of our tools have then been implemented by the bigger software vendors, including even, as a Grasshopper to Revit was one of the reasons why I started using IFC a lot. And now you see McNeil doing a lot of that work, or ArchiCAD with their live link, and Tekla producing their own live link, etc. So a lot of these interoperability tools that Geometry Gym started developing 8 years ago are now being done in a more mature way by the bigger vendors. I guess there's questions to my mind about, does owning the product motivate superior development? So by owning Geometry Gym and being invested in it, it certainly motivates to improve it and work on it full time. It does take a lot of effort to technically support these tools. So, it's not just the development of the code is only a part of the effort. And we saw a lot of Ehsan's presentation on producing documentation. So, how do you fund all that work and allow that to happen? So I'm definitely seeking enlightenment and evidence, and where to from here, I don't know. We have considered possibly crowdfunding Geometry Gym to open source it. Should we just get Geometry Gym as a commercial product like McNeil have done with Rhino and then use that to fund other open source projects? I really don't know, but certainly it's something of interest to us. Speckle, I want to give a huge plug for. I guess many of you have seen the news that Dimitri and Matteo have actually stepped out full-time working only on Speckle by themselves. So they're certainly going to need support from all their users to do that. So including financial contributions. So I'm not sure exactly how that's going to be facilitated yet. I haven't had a discussion with them, but certainly if we want to see projects like Speckle succeed, then we do need as an industry to support it and others to allow it to take place. I'm going to change a little bit off open source a bit and talk about open BIM and open standards and interoperability, as I sort of alluded to before. So this is an ARP project, Lachlan's Line Bridge in Sydney, which has actually just been lifted into place. I assume it will open sometime later in the year or next year when they finish off all the railings and finishes and stuff to the deck, etc. And it's a really interesting demonstration or insight into different modern and different workflows downstream. This one shows a lot of structural analysis by the engineers, a Revit model produced to produce documentation. We actually did also work on the interoperability through to Tekla to allow a fabrication model to be produced, although in the end that model was produced independently by a different company. So that one didn't quite get all the way from design to in a single tool chain or interoperability or single source of model. For those that aren't aware of Building Smart, so Building Smart is a non-for-profit industry or organization that is responsible for developing and maintaining open standards, not just IFC, they have several standards, but certainly IFC is the key standard that Building Smart are available for or responsible for. So here's some URLs here for the main Building Smart International website. For those here in Australia, the Australasia chapter website where I'm involved, and then also the digital forums where a lot of discussion can happen around the use and the technical details of the standard. This might be a slightly controversial quote to put up, but I was on the Hyper Discord forum last week, and I saw a very interesting quote posted about Unix was that those who don't understand Unix are condemned to reinvent it poorly, which is quite an interesting thought. And I guess being with a Building Smart bias and hat, kind of thought that I could apply that quote perhaps to industry foundation classes. So it is a complex data structure. It's capable of all sorts of disciplines and processes and use cases, but it years and years of intelligence poured into it, reaching global consensus around a data model. And it's certainly been very useful to Geometry Gym when we were looking at interoperability and how, I as a one-man band for the first few years, I didn't really have time to develop my own BIM data model. And what I was able to do was spend some time studying and researching and understanding what OpenBIM or IFC provided, and then being able to leverage that and concentrate on developing the tools that used it rather than having to try and design that data model. It certainly can be made more specific or optimized and made more efficient for particular use cases, structural analysis. So you do see quite a lot of structural analysis models being worked on now and produced in the past, but it is a very capable, comprehensive data model, and it's very rare that for all the work I've done, had to try to think about how to extend and support it, although we'll talk a little bit in this. Actively at the moment, it's being particularly developed for use in infrastructure projects. So that's something that, and it is actively being developed and improved. So again, if you do spend the time to use it and find it could be improved, then the opportunities are there to either provide that feedback or get involved in improving it within the Building Smart organization. IFC is used for lots and lots of different use cases. So for visualization, then a triangulated mesh is certainly suitable for visualization, clash detection, model coordination, etc. But IFC is capable of sort of parametrics even and sort of sophisticated breps and sweeps and many more coming in with the alignment and linear positioning, etc. So I guess that's where it starts to get confusing for users. Certainly there's lots of improvements that could be done in documentation. The question before about common user interface is an interesting one. But yeah, it's a data model that's capable of a lot. This gives you a little bit of an idea of a roadmap that IFC's been working to. It emerged about nearly 20 years ago, I think, and we're at the moment looking at producing IFC 5, a modernized version of IFC, and then beyond to smart cities and digital fabrication, etc. That I think all these things are reliant on improvements and enhancements to the IFC data model. Alignment and linear positioning, etc. These are some of the improvements that have been made to IFC recently. The infrastructure extension for IFC 4.3 has been published as a release candidate just this week. So again, I can share some details. So there'll be a lot of activity in implementing and testing and validating that for the rest of the year. IFC is capable of all sorts of model exchanges, including 4D construction sequences, structural analysis. So how do you extract or exchange a structural analysis model from an architectural or engineering BIM is something that it is capable of. And Dion also mentioned before about a list of various open source offerings and options for using IFC, and there's a lot of closed source options as well, as has been discussed. So OpenBIM, proprietary file, why OpenBIM and why open data models? Proprietary file formats basically allow vendor lock-in, which is really only of benefit to that vendor. If we want our digital to outlive their physical life, which could be 50 or 100 years, then are we really that confident that the existing software vendors today will be around in that time? And I mentioned before about whether smart cities and construction tech can really reach its potential using proprietary formats. I'm a bit of a skeptic of that. If everyone has a different way of representing something, how do you get that understanding across the different tools? IFC isn't perfect, and I'm certainly not going to say that, but it is being improved, and certainly the more feedback Building Smart can get and activity to improve it, the better. I would say IFC is capable of a lot more evident in existing implementations. Pretty much all the existing implementations are just focused on coordination model exchanges. I think infrastructure will be a great test for design transfer. So how do you take a model intelligently from one application to another? I think so that's going to be quite exciting to be involved in this year, looking at more advanced use cases of IFC about doing that. So I'm certainly not advocating for all AEC software solutions to be open source. I think there is a role and a place for proprietary businesses built around the tools. But I am a keen believer in the idea that the data model should be interoperable and should be based on ISO standards, and then the softwares compete on how to author and maintain that data model, not on locking in onto their own data model as part of that. That might be wishful thinking, and that might be some time away. But I think I'm a big believer that that's where we should be aiming and working to. So I also really think that clients and asset operators are really the key to OpenBIM reaching its potential, and it's quite nice to see, particularly here in Australia and around the world, governments starting to really talk up about OpenBIM deliverables and open standards and things like that. So I think that will make a huge difference into the quality of support of IFC within our various software vendors, and look forward to that improving. So that's much what I wanted to talk about today. I'll check if there's any questions, but thanks a lot for listening and the opportunity to give some insights into open source and open standards from the Geometry Gym perspective.
Thank you very much, John. We have one question, and also, Dion, if you have a question as well, you can turn on your mic and ask. I have one myself regarding what's happening on the OpenBIM space. As someone looking from outside, it seems like there are a lot of works in the OpenBIM space running in parallel. A lot of them look like unfinished, work in progress products. Why we haven't been able to join forces. Like, for example, every open source project in the AEC these days seems to have their own version of elements library, like starting from wall, door, and window, defining those objects and moving on, and also like their own, sometimes their own geometry library starting from points and lines. Why do we have like so much different opinions about one single thing that is being basically used by everyone, and that is like we want a library that has a wall with all sorts of properties that is needed. Why can't we just maybe use one big library and share it around different open source projects?
Well, I'd like to think we can, but it's not happening right now for a number of reasons. I think IFC is not perfect. It's very comprehensive and capable of a lot of disciplines, etc. So you lose off a lot of efficiency, and it makes it a lot harder for a new software developer to understand it. There is work being undertaken to simplify IFC, which hopefully improve that. You know, even the documentation of it, as we've acknowledged a couple of times, could be improved a lot to make it easier for the developers to understand it and then be able to learn it and use it. I think that some of those, you know, some developers do look at IFC and basically give up pretty quickly because, you know, but the better technical support can help do that. You know, IFC is head and shoulders above any other data model that's being developed, to my knowledge. And it can be improved. I don't think we should typically be out with the bathwater and start again from scratch, because we'd lose a lot of that consensus and understanding that's already been developed. But by, you know, improving the developer experience will make a huge difference to discourage other developers from walking away and starting their own implementation or version of the same thing. Particularly on geometry, Building Smart didn't even develop that part of the data model. That's all based on STEP as a ISO standard independently. And, you know, having done a lot of development work, particularly with Rhino Common, that STEP description is very distant with, say, how Rhino Common defines a lot of those concepts. So I do think it can happen, but there's also a lot of inertia in existing software developments, and how they would switch and change is obviously something that needs to be considered. But infrastructure projects where there's not an abundance of BIM tools does give a new opportunity to really try and test this and get that consensus and consistency in my point of view.
Mm. There's another question regarding the BOM project, BHM, the Brewer-Happold, I think, interoperability tool. So what's your insight on that?
Yeah, so I mean, Elaine's here commenting, so he'd probably be better to explain it than I am. But my insights into that is that it's again, you know, if you look at IFC, particularly from a structural analysis point of view, it's a very verbose data model, partly because it inherits from other disciplines and it's capable of a lot of other sort of representations. So IFC is not really a particularly efficient way in its current format to store something like a structural analysis model. And that's, I guess, another reason why you end up with something like the BOM being developed. As I said, there's a number of other structural analysis storage models, DSTV, Speckle's even been working on their own recently. And even Geometry Gym. I mean, I only learnt about IFC a few years after having started develop some of these structural analysis plugins in Grasshopper. So we tend to use our own structural analysis model behind the scenes that's closely related to our GSA software data model. But yeah, look, again, there could be improvements to IFC, particularly in that aspect that might discourage some of these sorts of things. But you know, IFC can't be everything to everyone either. So it's not to eliminate alternatives for specialist representations of aspects of our built environment. But obviously, the more common ground that we have across them, the better that interoperability will be.
And I think it's also one of the beauties of open source that everyone can like fork their own project and start something fresh or something that is linked to the main project. It's really great. Yeah. Another question that it's like an entry point question from people who want to start contributing to open source, but they don't actually really know about coding or they just have started. What would be your advice to someone who wants to start contributing to open source?
Yeah, that's a good question. I guess, and I sort of didn't intend to study computer science when I went to university, but I had been a computer geek for a long time. My mother used to teach commerce and typing and had a new typewriter called a Commodore 64 when I was a little boy. But I mean, it's easy to read code, so certainly reading and looking at open source projects is a good way to start. I think most people would suggest, rather than trying to write a lot of functionality up front, look at trying to find issues and debug the code so that you can understand it and maybe try and make small fixes. I know what's common in bigger software companies is partnering when you develop code. So actually sitting and watching someone else code, you can learn and get insights and understand better what's happening. So I've seen, I guess, particularly given we're all stuck inside, and even before that, some other software developers maybe share their screen while they're programming. So if you're considering and wanting to get involved in something like that, then watching some of those sessions and joining in it's probably a great way to try and start. And you know, again, we could discuss on forums and stuff, but I know even Nathan, who's been doing more and more coding since he joined me, could probably give some better resources on short courses and tutorials and things like that can help in that particular process.
So if anyone doesn't know to code at all, can they also be contributors to open source?
Well, especially in documentation, as Ehsan very much highlighted, and technical support of open source projects. So, you know, in some ways it's better for the developer not to be the technical support because they understand exactly how it works, whereas someone coming at it with fresh eyes could, and you know, without that legacy, better understands how to explain to someone else how to use it. So, yeah, I think great if you can get a lot of open source participation, not just from developers.
Yeah, and I think the thing is that just to maybe use the software and provide feedback to the developers can be also a way to help.
Absolutely.
All right, looking at the questions, the question about Hyper Elements library. Any opinions on that? We kind of touched on it, but
yeah, look, again, Ian and I mean, Ian's also done a bit of work with IFC and also still decided to develop elements. So, I mean, a good follow-up session would be to get his opinion on his experience with IFC, which I understand is probably quite frustrated due to some of this lack of modern development process and documentation. But certainly Hyper's a very interesting development, and I'm still looking at how we might get involved and support and help develop that platform. So
awesome. Well, thank you very much. I think that's pretty much it. We can wrap up here and go into the breakout rooms. Well, thanks everyone. If you've been watching the presentation, that's the end of the presentation here. And I hope that you like the presentation, and yeah, make sure to keep in touch with the presenters if you have any questions. And yeah, that's it. Thanks again. See you.